Hey guys, Chris here. Welcome to my second video. I couldn't find any video material for this part, so I just decided to film myself. I hope you'll enjoy the video, and let's take a look what we are going to create. This video builds on the first video of the series, so I created a playlist that you can access by clicking on the suggested video where the arrow is pointing at, or just go to my channel and find it via the playlist tab. That should help you to watch the videos in the right order. My goal is that every viewer can follow along without any issues, so I'd recommend using the exact setup from the first video. If something still doesn't work, please leave a comment, I'll try my best to help you fix it. Let's get started. First, we need to install Visual Studio, cause we'll create two scripts in this project. To install it, you can either go to your Unity version in Unity Hub and add Visual Studio as a module, or download it from the visualstudio.microsoft/downloads website, install it, and then add Game Development with Unity through the Visual Studio installer. Next, we can create our project via Unity Hub. We want to create a 3D project and let's name it Ball Jump. When the project was created, the first thing we should do is installing the necessary packages. For this, we need to go to Window and then Package Manager. There we need to select Preview Packages and then search for ML to find the ML package. Even if you've installed it in the last video, you need to do it again, because the packages are added to this specific project. And, well, this is a new one, so we need to add it. I'm installing version 1.0. I'd recommend you using the same versions as I do to avoid any problems. The last package we need is called ProBuilder. You will later see why. I'm installing version 4.2.3. With the packages installed, we can start creating the environment. The first thing I like doing is creating some folders to structure the files and objects we are creating. Besides the Scenes folder, I'm going to create the folders named Materials, Prefabs, Scripts, and Brains by right-clicking in the Assets window and selecting Create and then Folder. Second, we should rename the scene. Let's rename it to Ball Jump Scene. Now we are going to create the necessary game objects by right-clicking in the Hierarchy window and selecting 3D Objects. Let's start with a plane. You can now see we can modify the plane object via the inspector on the right. I'm going to change the name to Floor and set the X scale to 2 to make it wider. For the walls, we are going to use cubes. I'll start with the left wall. You can either change the position by dragging the object around or set the position via the inspector. I'm using the position 9, 0.25 and 3.5 and a scale of 2, 0.5 and 3 to change its position and shape. For the second wall, we can just copy the left wall by selecting it in the hierarchy and pressing Ctrl+C followed by Ctrl+V, and then change its name to right wall and set the position Z from 3.5 to -3.5. Now we are going to create the ball object by selecting Sphere in Unity and naming it BallAgent. Even if it sounds a bit weird, the word agent is the most commonly used naming convention for a reinforcement learning AI, so I'll stick with it. For the position of the agent, I'm using the values -9, 0.5 and 0. For the target, we need to create another cube. I'm going to name a target and set its position to 12, 3 and 0. But in this case, it's just that it looks good in the setup, cause we'll later write code that randomizes the target position in a specific area when running the simulations. The last game object we need to create is the ramp. Since the ramp is not a default object like the cube, we need to build it. For this, the package ProBuilder that we installed earlier comes in handy. Let's start it by clicking on the Tools tab and then open a ProBuilder window. Now we can create an object by pressing Ctrl, Shift and K. You should see a second window. In there, we can select the prism shape and change x to the value 2 so that it's not too steep. It is important to click on Build before closing the windows, otherwise it is not saved. Lastly, we can rename the object to ramp and set its position to 8, 0 and minus 0.5. Let's finish the environment design by making the walls and the ramp black and the BallAgent cyan. For this, we should go to the materials folder we created and then create a material by right-clicking, selecting Create and then Material. I name it Black and set the color to black in the inspector. Same for cyan. If you don't know the color code for cyan, it's red 0, green 255 and blue 255. Now we go to our game objects where we want to apply the material onto and drag it in the inspector onto the materials element 0 row. Same for the other objects so that the walls and ramp are black and the BallAgent is cyan. You can save your current environment by pressing Ctrl S to avoid any loss when Unity or your PC crashes. When there are unsaved changes, you'll see a star behind the scene name. After saving, you should see that it's gone. With the environment set up, let's honor the BallAgent by actually making him an agent. For this, we first add a rigid body component so that physics from the Unity physics engine are applied to the BallAgent. Then we go to our scripts folder and create a C# script that we later add to our BallAgent. Let's call the script BallAgent Logic and open it. To understand the following part, you should have a good understanding of coding basics. If you don't have any coding experience, I'd recommend downloading the script and dragging it into the scripts folder to avoid any issues. The download link can be found in the description. The same applies for the second script that we are going to create later. What you can see now is the default structure of a new script. We don't need some parts, so let's remove them. What we need to import though are the unity.mlagents and unity.mlagents.sensors packages. The former provides a class named agent from which we inherit. To successfully train our agent later, we need to override 3 methods called onEpisodeBegin, collectObservations, and onActionReceived. Before we start with the onEpisodeBegin method, we need to define a rigid body variable and assign it in the start method. Since this script will be attached to our agent, we can just use getComponentRigidBody, which will return a reference to the rigid body component of our BallAgent. We also need a transform variable, which I name target, to be able to read and change the x, y, and z position of the target. But target is just a variable name. How do we get the actual reference loaded into it? Let me show you. Make sure to save the script with Ctrl S so that it's updated in Unity. Let's switch to our Unity window and attach it to the BallAgent by dragging it in the inspector window. We can now see the script component, which has a field called target. If we now select our target object in the hierarchy window, we can drag it in the target field of our script. The target variable now holds a reference to the target. Pretty convenient. You might have noticed that another component called behavior parameters was automatically created when we added the script. That is because our class inherits from the MLAgents class named agent, which depends on those behavior parameters. Therefore, it is automatically created when we add our script to a game object. Okay, back to the script. In the onEpisodeBegin method, we need to define what should happen when a new episode begins. In the onActionReceived method, we'll later determine when exactly an episode is over. First, we set the forces applied to the BallAgent to 0 and set the BallAgent to the start position. We also want to reposition the target. Otherwise, it would be quite easy for our agent if the target doesn't move. For this, we set the x position to a value between 12 and 20 to define how far the target is from the ramp, which is at around 8. The y position is set between 0 and 3, so that the target changes its height. Z is in a range between -5 to 5 to represent the whole width of the floor. That's it for the onEpisodeBegin method. Let's head to collectObservations. This method is quite easy when you know what you want the agent to know during training. In our case, the agent gets 9 observations every time step. 3 for the x, y, and z position of the target, another 3 for the x, y, and z position of the agent itself, and 3 more for the agent's x, y, and z velocity. But that alone would result in an error, cause we also need to explicitly define that we have exactly 9 observations in the behavior parameters by setting the vector observation space size to 9. And while we are on it, let's set everything. The name is the name we have to use in the config later. That's important to keep in mind. I name it BallAgent. For the vector action, we are using the space size discrete with 2 branches of size 2 and 3 respectively. Therefore, the possible action values in the first branch are 0 and 1, and 0, 1, and 2 in the second branch. Before we start with the onActionReceived method, let's create and set a variable called speed to 20 that can be changed through the inspector. I won't change the speed value in this video, but I've done so when playing around with it, and you might be interested to do so too. Keep in mind that you'll need to retrain the agent cause he is not familiar with suddenly being that fast or slow. Okay, let's head to the onActionReceived method. This method gets executed every time the agent decided what action values to take. But how do we define how often the agent should make a decision? For this, we need to add a decision requester component to our agent. Don't worry, it's the last component we need to add. I'm going to set the value of the decision requester to 5 so that the agent takes a decision every 5th time step, which is still multiple times per second. You can also play around with this value, though I wouldn't recommend it for the beginning. Let's start with applying forces based on the actions we receive from our agent. For this, I'm going to create a 3-dimensional vector named controlSignal. Then we read the action that the agent shows and assign it to the x value of our controlSignal vector. The action is either 0 or 1, which matches the forces where 0 is not moving and 1 is moving forward. Therefore, the agent is not able to move backwards, which makes sense in our environment. The second action gets assigned to the z value of the controlSignal so that the agent can roll to the left and right. Since we get the actions 0, 1, and 2 from the agent, we need to map them because the forces for left and right are -1 and 1 respectively. The action 2 gets mapped to the value 1, the action 1 to the value -1, and action 0 results in the value 0. Now that we've set the controlSignal, we need to add the forces to the agent. That can be done by applying the addForce method to the agent's rigid body component. The controlSignal is multiplied by the speed variable we created so that we can easily modify the acceleration speed. You might have noticed that the comment is wrapped inside the if statement. That is to avoid the agent being able to accelerate behind the top of the ramp, which is at around x equals 8.5. The agent should get a reward when reaching the target. We can easily calculate the distance between two vectors with the distance function. In our case, the vectors are the position of the agent and the target. If both are close enough, we give the agent a reward of 1 and end the episode. The episode should also end when the agent fell off the platform. This can be easily determined by reading its y value, which becomes negative when the agent is falling. With this setup, we could start the training via the ML-agent's learn comment, but I'd recommend doing a few things before training. First is testing the environment. It's as easy as 3 lines of code and 1 change in the inspector. Let me show you. In the behavior parameters is a setting called behavior type, which has to be changed from default to heuristic only. Because of that change, the actions are not determined by the agent anymore, but by whatever we write in the heuristic method. With the 2 lines in there, we map our keyboard input to the action space so that we can control the ball with the arrow keys. The only difference is that we can roll backwards, but the agent can't. Before we start testing the environment, we should reposition the camera. I'm using the position -13, 2, and 0, and a 90-degree Y rotation to get a clear view. Now we can start testing by clicking on the play button. You can see that we didn't only create an environment for our AI, but also for us. Wouldn't it be nice though if the camera follows the ball? It's actually quite easy. First, we go to the scripts folder and create a new script. I call mine BallAgent follow. Then we open the script and add 4 lines of code. The first line gets a reference to the ball agent's position. The second creates a 3D vector variable. The third line initializes the variable with the distance to the ball agent. The last line repositions the camera each frame so that it follows the agent. Please note that we should use the lateUpdate method and not the update method to update the camera position after the update step. Now we can add the script to our main camera object and add the BallAgent reference to the BallAgent transform variable. That's it. Let's start the environment again. Good, that's working. So let's start training now. Nope, it would take too much time. Why not duplicating our environment, for example, 20 times to train 20 times faster? I'll show you how. Let's first set our behavior type back to default. Now we create an empty game object, name it training area and set its position to 0, which is really important, otherwise all objects will be misplaced after the next step. That is, dragging all objects that we created into the training area. So basically everything except the camera and light. When we now drag the training area object into the assets folder, a prefab gets created. Think of it as a template of our environment. The box next to the training area object should have switched to a blue color, which means that it is an instance of the prefab. If we'd now clone it multiple times and then change the prefab, the changes are reflected on all training areas in our scene. That saves us a lot of time when we want to do some changes. The training area object can be easily duplicated by selecting it in the scene view, pressing Ctrl+C followed by Ctrl+V, then dragging it to another position. When you drag, make sure to only use the blue and red arrow or the yellow square to avoid changing the height. You can repeat these steps multiple times till you have enough training areas to ensure a quick training. To see if your PC can handle more areas, check the load on CPU, GPU and RAM during the training process. So, let's start training now. Guess what? Nope. One more thing to do. Configuration. For this, we need to open the trainer config YAML file inside the config folder of our downloaded ML Agents repository. If you have no idea what I'm talking about, make sure to go through the first video of this series. You can use a program of your choice to open the file. I'm using Notepad++. What if we wouldn't add a configuration for the BallAgent at all? Well, it would just use the default config, which might work, but it's not optimal. So I created a specific configuration for the BallAgent that ensures a good and stable training. You can find a download link for the configuration file in the description. I won't go through the configuration parameters, cause I think there's already a lot to process in this video. But I'll definitely make a video about all parameters with their meanings and effects, probably the next one. Or what would you like to see in the next video? Let me know. Can we start training now? Yes, finally. Same comment as in the first video. Only thing I would change is setting the run ID to something like BallAgent training, which creates a folder of the same name under models in your ML Agents folder. If you want to use the same name again for another training procedure, you'll get an error to prevent overwriting your old training files. If you still want to overwrite them, you need to use the ---- force argument. The camera follow might look a bit weird during training, cause it's running so fast. By deactivating the script component that is attached to the main camera, you can easily disable the camera follow logic. Make sure to activate it again after training is finished. The agent will train for 2 million steps, which might still take some time depending on how many training areas you have. If you want to decrease the number, just change the max steps parameter to a lower value. After training, you'll find a .nn file in your models subfolder. Drag it into the brains folder in Unity and from there into the model row in the behavior parameters. Start the scene and enjoy the results. There's many information to process in this video. I'd recommend taking your time and going through it step by step to make sure you understand the underlying concepts. If you have any questions, feel free to ask. This video took quite some time and effort to create. If it somehow helped you, it would mean a lot to me if you could take a few seconds to leave a like. If you want to see more videos like this, make sure to subscribe and hit the notification bell to get a notification when I upload another video. Thank you very much, and I hope to see you in the next video.